In this video, I'm going to show you how to solve a typical problem that traditional methods refer to as the inverse simple rule of 3. Before anything else, I want to remind you of what I told you in the previous video, that inverse magnitudes do not exist and that traditional methods are based on two physical theories that have not been proven, so you have to be very careful. However, the method I am proposing to you and that I am going to teach you in this video, just as I did in the previous video, is a method that has been approved through double-blind peer review on 2 different occasions. In other words, it has been accepted by the scientific community, once in Spanish and once in English. I have left a link in the description to the 2 corresponding articles, which contain the same content, but where I demonstrate that this method is applicable to any problem of this type. This method is based on the First Algebra of Magnitudes. Alright then, let's begin with the problem at hand for this particular case. It says, a faucet that dispenses 18 pints of water per minute takes 14 hours to fill a tank. How long would it take if its flow rate were 7 pints per minute? Let's proceed in order. First, let's distinguish between the statement and the question within this problem. What is the statement? The part where all the data is given to us. That is, a faucet that pours 18 pints of water per minute takes 14 hours to fill a tank. Perfect. So what is the question? How long would it take if its flow rate were 7 pints per minute? Now we've distinguished within the problem the statement part from the question part. Great. What do we have to do now? We need to establish the equality between the measurements that represent a resource and the measurements that represent the final work we want to achieve. And we need to do this first for the statement and then for the question within this problem, so we should end up with 2 equalities. Let's go to the statement part. A faucet that pours 18 pints per minute. There we have the first measurement. Is it a resource or a result? It's a resource. So 18 pints per minute times, it says it takes 14 hours. So that times would be 14 hours. To achieve what? The final result, which is the tank we fill. So here we have the first equality. First thing I need to clarify regarding the previous video, which didn't come up before. If you notice, we're multiplying 18 pints per minute by 14 hours with an asterisk. Why are we multiplying with an asterisk? Because we are with algebra of magnitudes. As you can see, I haven't removed the magnitudes. I have kept them because we are operating with these magnitudes. So we need to distinguish this multiplication from purely arithmetic algebra. We can't indicate this multiplication with a dot or an X because, I repeat, we need to distinguish between arithmetic and geometric algebra. Alright, with that clarified, we now have the first proportion for the statement. Let's look at the proportion for the question, trying to keep the same order as in the statement. Not for any particular reason, just to clarify things so you don't get confused. It's not strictly necessary, okay? So it says, how long would it take if its flow rate were 7 pints per minute? Here we have the first measurement, 7 pints per minute. And then, how long would it take? The second measurement is where we find the unknown. We're measuring time in hours, just like in the problem statement, okay? What we don't know is how many hours. So, in that measurement of x hours, the numerical element is our unknown. The dimensional element, which is hours, time, we do know. Perfect. For what purpose? What is the final task? Well, it doesn't specify anything. That is, it's telling us exactly how long it would take to fill that same tank with that flow rate. So, the work is the same. Once we've got this, what do we need to do? Just like in the previous exercise regarding the very simple and straightforward direct rule of 3, if we carefully divide both sides of the 2 distinct equalities, we will then obtain a single, comprehensive equality that precisely forms the fundamental proportion for the entire and complete problem at hand. Now, since we're still working with algebra of quantities because we haven't yet eliminated the units from this proportion, we should indicate that division with a double horizontal line. From here, we already have the complete proportion. What is the next step? The first algebra of magnitude has proved that when a magnitude is divided by itself, it results on an abstract number, that is the unit. So what happens here? We have pints per minute divided by pints per minute. That gives an abstract number, which is 1. We also have hours divided by hours, which also gives 1. And again, we have tank divided by tank, which also gives 1. What happens? We're now left with a relatively simple arithmetic operation, specifically 18 times 14, which is then divided by 7, and finally multiplied by the variable x. And what is this equal to? To 1 over 1. From here we just solve for x, and what do we get? 18 times 14 divided by 7. What is that equal to? 36? X is 36. If we go back to the original unit, which was x hours, the unit where we found the unknown, then we have that. The time it takes to fill that tank under these new conditions or with these resources is 36 hours. If you want me to solve a specific problem, just let me know in the comments. What I do ask, please, is that you help me spread the word about this method. Thank you very much.